Welcome. Today we are looking at electromagnetic induction. This is topic 7 in your SS2 physics series. This topic is frequently tested in objective questions in your examinations. Pay close attention. Let us begin. First, let me explain what electromagnetic induction is. Electromagnetic induction is the production of an electromotive force in a conductor when it is exposed to a changing magnetic field. It is the process by which electricity is generated from magnetism. This phenomenon was discovered by Michael Faraday in 1831. It is one of the most important discoveries in physics. It is the basis for electrical generators and transformers. Without electromagnetic induction, modern electrical power systems would not exist. Understanding electromagnetic induction is essential for understanding electricity generation and transmission. It is essential for understanding motors, generators, and transformers. Now let me explain Faraday's law of electromagnetic induction. Faraday's law states that the induced electromotive force in a circuit is directly proportional to the rate of change of magnetic flux through the circuit. The formula for Faraday's law is EMF equals minus N times delta phi over delta T. EMF is the electromotive force. N is the number of turns in the coil. Delta phi is the change in magnetic flux. Delta T is the change in time. The negative sign indicates Lenz's law. Lenz's law states that the direction of induced current is such that it opposes the change that produced it. Understanding Faraday's law is essential for understanding electromagnetic induction. Now let me explain Lenz's law. Lenz's law states that the direction of induced current is such that it opposes the change that produced it. It is a consequence of the law of conservation of energy. When a magnetic field changes, a current is induced. The induced current creates a magnetic field that opposes the change. For example, if a magnet is moved towards a coil, the induced current creates a magnetic field that repels the magnet. If a magnet is moved away from a coil, the induced current creates a magnetic field that attracts the magnet. Understanding Lenz's law is essential for determining the direction of induced current. Now let me explain the factors affecting induced electromotive force. The induced electromotive force depends on several factors. The first factor is the rate of change of magnetic flux. A faster change produces a larger EMF. The second factor is the number of turns in the coil. More turns produce a larger EMF. The third factor is the strength of the magnetic field. A stronger field produces a larger EMF. The fourth factor is the area of the coil. A larger area produces a larger EMF. The fifth factor is the angle between the field and the coil. The EMF is maximum when the field is perpendicular to the coil. Understanding these factors is essential for maximizing induced EMF. Now let me explain the methods of inducing electromagnetic induction. There are several methods. The first method is moving a magnet into or out of a coil. This changes the magnetic flux through the coil. The second method is moving a coil into or out of a magnetic field. This also changes the magnetic flux. The third method is rotating a coil in a magnetic field. This continuously changes the magnetic flux. This is the principle of the generator. The fourth method is changing the current in a nearby coil. This changes the magnetic flux in the second coil. This is the principle of the transformer. Understanding these methods is essential for understanding how generators and transformers work. Now let me explain the principle of the electric generator. An electric generator converts mechanical energy into electrical energy. It uses the principle of electromagnetic induction. A coil is rotated in a magnetic field. As the coil rotates, the magnetic flux through the coil changes. This induces an electromotive force. The induced EMF produces a current. The current is collected by brushes and commutators. There are two types of generators: AC generators and DC generators. AC generators produce alternating current. DC generators produce direct current. Understanding the electric generator is essential for understanding electricity generation. Now let me explain the principle of the transformer. A transformer is a device that changes the voltage of alternating current. It consists of two coils, the primary coil and the secondary coil. They are wound around a common iron core. The primary coil is connected to the input voltage. The secondary coil is connected to the output voltage. When alternating current flows through the primary coil, it creates a changing magnetic flux. This changing flux induces an EMF in the secondary coil. The voltage ratio is determined by the turns ratio. The formula is V's over Vp equals Ns over Np. V's is secondary voltage. Vp is primary voltage. Ns is secondary turns. Np is primary turns. Transformers are used for stepping voltage up or down. Understanding transformers is essential for understanding power transmission. Now, let me explain the principle of the electric motor. An electric motor converts electrical energy into mechanical energy. It uses the principle of electromagnetic induction. A current-carrying coil is placed in a magnetic field. The coil experiences a torque. This causes the coil to rotate. The rotation produces mechanical work. The motor is the reverse of the generator. Motors are used in many applications. Examples include fans, pumps, and electric vehicles. Understanding the electric motor is essential for understanding how electrical energy is converted to mechanical energy. Now let me explain the applications of electromagnetic induction. Electromagnetic induction has many applications. In generators, it is used to produce electricity. In transformers, it is used to change voltage. In motors, it is used to produce motion. In induction cooktops, it is used for cooking. In wireless charging, it is used to charge devices. In magnetic levitation, it is used for transportation. Understanding the applications of electromagnetic induction is essential for understanding modern technology. Now let me explain alternating current and direct current. Alternating current changes direction periodically. Direct current flows in one direction. AC is produced by AC generators. DC is produced by DC generators or rectifiers. AC is used for power transmission. DC is used for electronics and batteries. The frequency of AC is the number of cycles per second. It is measured in hertz. In Nigeria, the frequency is 50 hertz. Understanding the difference between AC and DC is essential for understanding electrical systems. Now, let me explain the root mean square value. The root mean square value is the effective value of alternating current. It is the value that produces the same heating effect as direct current. The formula for RMS voltage is Vrms equals V peak over square root of 2. The formula for RMS current is IRMs equals I peak over square root of 2. RMS values are used for AC measurements. Multimeters measure RMS values. Understanding RMS values is essential for understanding AC circuits. Now, let me explain the importance of electromagnetic induction. Electromagnetic induction is important for several reasons. First, it allows the generation of electricity. Most of the electricity in the world is generated by electromagnetic induction. Second, it allows the transmission of electricity. Transformers use electromagnetic induction to change voltage. Third, it allows the conversion of electrical energy to mechanical energy. Motors use electromagnetic induction. Fourth, it supports many technologies. Electromagnetic induction is used in induction cooktops, wireless charging, and magnetic levitation. Understanding electromagnetic induction is essential for physics and technology. Now let me give you sample exam questions. Define electromagnetic induction. Electromagnetic induction is the production of an electromotive force in a conductor when it is exposed to a changing magnetic field. State Faraday's law. Faraday's law states that induced EMF is proportional to the rate of change of magnetic flux. State Lenz's law. Lenz's law states that the direction of induced current opposes the change that produced it. State the factors affecting induced EMF. The factors are rate of change of flux, number of turns, magnetic field strength, area of coil, and angle. Explain the principle of the transformer. A transformer changes voltage using electromagnetic induction. State the formula for the transformer. Vs over Vp equals Ns over Np. Let me summarize. Electromagnetic induction is the production of EMF from a changing magnetic field. Faraday's law states that induced EMF is proportional to the rate of change of flux. Lenz's law states that induced current opposes the change. Factors affecting induced EMF include rate of change, turns, field strength, area, and angle. Generators convert mechanical energy to electrical energy. Transformers change voltage. Motors convert electrical energy to mechanical energy. Electromagnetic induction has many applications. Understanding electromagnetic induction is essential for physics and technology. Practice these concepts. When you have them down, move to Topic 8.